Today I'd like to talk about something called Lewis dot diagrams. Now, Lewis dot diagrams is actually a fairly simple concept about that ties later into much more complicated concepts such as molecular geometry, the Vesper theory, and Lewis structures. So this is actually a very important stepping stone. So to start Lewis dot diagrams, what I'll start with is defining something called valence electrons. Valence electrons. Now, these are basically the electrons in the outermost shell. So the electrons in the outermost shell. So the electrons in the outermost shell. So if we were to look at an element, let's take, just for the sake of discussion, let's take oxygen, because everyone loves oxygen. So if we take oxygen, I'm going to actually, okay, let's denote the shells with different colors. We know what's the electron configuration for oxygen. Well, oxygen, the electron configuration for it is 1s2, 2s2, 2p4, right? Because oxygen has eight electrons total. Now, what are the valence electrons? Well, they're the electrons in the outermost shell. In this case, these 6 electrons are the valence electrons. Now, here's a little more visual representation for you. So here's our 1s shell, and here is our 2s shell outside of it, and 2s/2p. Now, let's draw the electrons. Now, inside of our 1s shell, there's 1s2, then here's 2s2, and then we have 2p4. Now, if we look at the valence electrons, are the electrons in the outermost shell. So, let's take a look at this here. We have 1, 2, 3, 4, 5, 6 in this outermost shell. So those are what valence electrons are. And you'll see why these are so important in just a minute here. So if we scroll down a little bit, and we will see what Lewis dot diagrams are. Lewis dot diagrams are basically a visual representation. Visual representation of the electron of valence electrons. So what does this mean, a visual representation of valence electrons? Well, let's show some examples of these Lewis dot diagrams. So here's a couple of examples for you. So we looked at oxygen up here. So let's look at oxygen again. So this is what a Lewis structure for oxygen would look like. And notice that we have 6 dots surrounding oxygen. Now these 6 dots represent the number of valence electrons. So with that said, let's get into the drawing of these valence electrons, of drawing Lewis dot diagrams. So drawing Lewis dot diagrams. Now, the first step is to sum the valence electrons. So there's the easy way to do this by, if you memorize that that if you have alkali metals, you get 1 valence electron. Alkali earth metals, you get 2 valence electrons. Boron family has 3, and so forth and so on until you get to the noble gases which have 8. Then that's easy. Or you could just do the electron configuration, and then look at whichever orbital whichever part of the configuration has the highest energy shell, and just look in an energy level and sum the electrons in that. So, for example, 1s2, 2s2, which happens to be the configuration for beryllium. We know that the highest energy level here is 2. So if we sum the valence electrons here, that's 2. So then beryllium has 2 valence electrons. So there are multiple ways that you can do that. The next step is to draw valence electron dots around symbol. So the symbol for the let's take beryllium, since we already used that up here. So if we have the symbol for beryllium, Be, what do we do now? We have to draw the 2 valence electrons that it has as dots. So we start at the top. You always start at the top. Then you must rotate 90 degrees clockwise so essentially going always to the right, and you draw the rest, then another dot. Now, if we were to look at something such as, which has a little bit more, let's look at, take boron. So if you have boron has 3 valence electrons. So we draw the symbol for boron, and we start at the top, and we move one more to the right, and so we draw a second one. Now we have one more valence electron dot to put, so we just move down like this. Now what if we notice that there are only 490 degrees in a full circle. So what do we do when we have not more than 4 dots? So more than 4 valence electrons. Well, if we look back at oxygen, when I created this oxygen example, what I really did was I took oxygen and I said, okay, oxygen has 6 valence electrons. So now I'll just draw the structure for oxygen. I have 1, 2, 3, 4 valence electrons. Now for the remaining 2, I just have to double it up. I just continue on my pattern and just double up the electrons. Now for something like neon, which has 8, it has a full shell, I would just do this. So I do neon has 8 valence electrons, and I would say neon, and I would go 1, 2, 3, 4. Now I've got a full circle. Now I just have to go again. 5, 6, 7, 8. And so this is about as far as you can get, because there are only a grand total of 8 valence electrons. Those are the noble gases. So 8 valence electrons. So you won't have to triple them up or quadruple them up. So this is about as complicated as it's going to get. Now, like I said, Lewis dot diagrams have an important place when you're talking about Lewis structures, which will be the next video, and VSEPR theory, which will be the videos after that, and such and so on. So let's just a quick recap on drawing them. Just sum out the valence electrons, and then draw the dots starting from the top and moving clockwise around the symbol. Thank you very much.